Right now, somewhere above your head, something is happening that space agencies are not talking about publicly. And the reason they are not talking about it is not because it is not serious. It is because they do not fully understand it yet. 72 hours ago, NASA's Space Weather Prediction Center in Boulder, Colorado went into a level of alert that most of the scientists working that shift had never seen before in their entire careers. Not a drill, not a precaution. A real, active, ongoing emergency response to something our instruments detected coming from the sun. What they saw stopped them cold. 4 separate regions on the surface of the sun erupted at the exact same moment. Not close to the same moment, not within a few minutes of each other. The exact same moment. Now if you are thinking, okay, the sun erupts all the time. Why is this different? I need you to stay with me here because this is where it gets genuinely frightening. These 4 regions are located in completely different parts of the sun. 2 in the northern hemisphere of the sun, 2 in the southern hemisphere. According to every solar model scientists have built over the last 60 years of modern space observation, these regions have zero physical connection to each other. There is no known mechanism that could cause them to fire simultaneously. The physics we currently understand says this should not be possible. And yet the satellites recorded it happening. Our sun is approximately 93 million miles away from Earth. It has been burning for 4.6 billion years. We have been seriously studying it for about 60 of those years. And in those 60 years, we have learned an enormous amount. We understand solar cycles. We understand how flares form. We understand the relationship between sunspot activity and geomagnetic storms here on Earth. But what happened 72 hours ago does not fit inside any of that understanding. Scientists at NOAA are calling it internally the quadrant event, because all 4 quadrants of the sun's visible face were involved simultaneously. And right now, the combined energy released by those 4 simultaneous eruptions is traveling through space at approximately 1 million miles per hour directly toward Earth. The arrival window is 67 hours from when this recording was made. To understand why that number matters, you need to understand what happened in Quebec, Canada in March of 1989. On the evening of March 12th, a geomagnetic storm caused by a single solar flare struck Earth's magnetic field. The storm was powerful but not the largest ever recorded. And in 92 seconds, the entire power grid of the province of Quebec went completely dark. 6 million people lost electricity instantly, in the middle of a Canadian winter. Temperatures outside were well below freezing, and the power stayed off for over 9 hours. That was caused by one flare from one region. What is currently headed toward Earth came from 4 regions firing simultaneously. Early energy calculations coming out of NASA suggest the combined electromagnetic output is somewhere between 8 and 11 times more powerful than the storm that took Quebec dark in 92 seconds. 8 to 11 times more powerful. And here is what that means for the world you live in right now. There are approximately 8,000 active satellites orbiting Earth at this moment. These satellites are not luxury technology. They are the invisible backbone of modern civilization. Your phone knows where you are because of satellites. Airplanes know where they are because of satellites. The global banking system uses satellite timing signals to synchronize transactions worth trillions of dollars every single day. Weather forecasting, military operations, internet connectivity across oceans, emergency response systems. All of it runs through those 8,000 satellites sitting up there in orbit. Every one of those satellites was built to handle normal solar weather. Engineers thought about solar flares when they designed them. They added shielding. They built in backup systems. They tested against known threat levels. But there is a number that engineers use called the index. It measures the intensity of a geomagnetic storm in. The Quebec storm in 1989 pushed that number to negative 589. That was considered an extreme event, a once-in-decades level storm. Current projections for the incoming quadrant event are showing potential readings between negative 800 and negative 1,200. Those numbers have never been recorded in the entire history of the modern satellite era. We do not have real-world data for what happens to satellites at those levels, because those levels have never happened while satellites existed. What we do have is physics, and the physics says that at those electromagnetic intensity levels, the shielding on most commercial satellites becomes essentially irrelevant. The energy simply overwhelms it. And here is something most people do not realize about satellites in danger. You cannot just turn them off and wait for the storm to pass the way you might turn off your computer during a lightning storm. Satellites need to maintain certain active functions just to stay in orbit. Attitude control, thermal regulation, basic station keeping. Shut those systems down completely, and the satellite begins to drift, loses altitude, and eventually becomes an uncontrolled piece of debris tumbling through one of the most crowded regions of near-Earth space. An uncontrolled satellite becomes a collision risk, and a collision in orbit does not just destroy two satellites. The debris from that collision travels at 17,000 miles per hour in every direction and threatens every other satellite in the surrounding orbital shell, which creates more debris, which threatens more satellites. Scientists call this chain reaction syndrome, and it is the scenario that keeps the people who run space agencies awake at night, because once it starts, it essentially cannot be stopped, and low Earth orbit becomes unusable for generations. But the danger does not stop in space. When a geomagnetic storm hits Earth's magnetic field, it does not stay up there. It pushes down into the ground. It creates what scientists call geomagnetically induced currents, which are essentially massive electrical surges that travel through anything that conducts electricity on the surface of the planet. Power lines, pipelines, railway tracks, and most critically, the transformers that sit at the heart of every major power grid on Earth. Transformers are the most vulnerable point in any electrical grid. They are also the hardest to replace. A large high-voltage transformer takes between 12 and 18 months to manufacture. They are custom-built for each location. There are no warehouses full of spare ones sitting around waiting to be installed. Each one that gets damaged in a major geomagnetic event is a minimum of a year-long problem for the region it serves. The United States Congress commissioned a report on exactly this vulnerability. The report found that a severe geomagnetic storm could cause damage to the North American power grid that would take between 4 and 10 years to fully repair. Not weeks, not months, years, with cascading failures in water systems, food supply chains, hospitals, fuel distribution, and communication networks following directly behind the initial power loss. This is documented. This is not speculation. This is what the people responsible for protecting this country's infrastructure have put in writing. And right now, those same people are quietly, without making any public announcements, sending alerts to utility companies, satellite operators, and grid managers telling them to prepare for an incoming event at the upper range of anything we have ever recorded. SpaceX has not made a public statement, but teams managing the constellation of over 6,000 satellites are actively working contingency protocols right now. GPS satellite operators within the United States military, which controls the constellation every person on Earth uses to navigate, are monitoring in real time. Power utilities across Canada, which sits at higher latitudes and is more exposed to geomagnetic events than the continental United States, have reportedly already taken some generators offline as a protective measure, accepting reduced power capacity now to reduce the risk of catastrophic equipment loss when the storm hits. All of this is happening, quietly, behind closed doors, while most people go about their day with no idea what is 67 hours away. Go back to 1859, before any of this technology existed, before satellites, before power grids, before any electrical infrastructure beyond the telegraph. In September of that year, a solar flare struck Earth and created the most powerful geomagnetic storm in recorded human history. We call it the event, named after the British astronomer who observed the flare. The storm was so powerful that telegraph machines across Europe and North America began operating on their own with no power connected to them, running purely on the geomagnetically induced currents flowing through their wires. Some telegraph stations caught fire. Operators received electric shocks from equipment that should have been completely safe. Auroras lit up the night sky as far south as Cuba. People in the northeastern United States woke up in the middle of the night, thinking it was morning because the sky was so bright. Scientists have studied the event extensively. Their conclusion is that if the same event happened today with modern electrical infrastructure, the damage would be measured not in billions but in trillions of dollars. And the disruption to modern life, which is infinitely more dependent on electricity than 1859, would be on a scale that is genuinely difficult to imagine. The event was caused by one solar flare from one region. We are currently tracking 4 simultaneous eruptions. There is no historical precedent for this. There is no model that was built to predict the outcome of a coordinated 4-region simultaneous solar event, because nobody who built those models ever seriously considered that it could happen. The assumption, based on 60 years of observation, was that the different regions of the sun operate independently. That assumption was wrong. What does this mean going forward beyond the immediate 67-hour window? That is the question that has solar physicists genuinely shaken right now. Because if 4 independent regions of the sun can synchronize their eruptions once, the question that follows is unavoidable. Can it happen again? Was this a one-time anomaly caused by some temporary alignment of subsurface magnetic fields we do not yet understand? Or does this represent something new about how the sun is behaving as we sit at the peak of solar cycle 25? We do not have the answer to that question yet. And the honest truth is that with a single data point, which is what we currently have, scientists cannot yet tell the difference between a strange coincidence and the beginning of a new pattern. What they can do, and what they are doing right now, is watch. Every solar observatory on Earth and in space is pointed at the sun. Every satellite with instruments capable of measuring what just happened is measuring it. Every solar physicist with access to the data is analyzing it. And Sky Pulse is going to be right here, bringing you every update as this situation develops over the next 67 hours and beyond. Because this is exactly the kind of story that deserves your attention, not the version filtered through press releases and carefully worded official statements designed to avoid causing concern. The real version, the version the data is actually telling us. The sun just did something nobody predicted, something our best models said should not be possible. And the wave of energy from that impossible event is heading toward Earth right now. If this video found you for the first time, subscribe to Sky Pulse and turn on notifications, because the next update on this event is coming very soon and you do not want to miss it. This is Sky Pulse. Stay alert. We will see you in the next one.